Nathaniel, and today we will now do step 3, question 3 of 2021. So let IN is this. Again, another reduction formula questions. I realize that STEP does this quite often in their calculus questions. So let us calculate half IN plus 1 plus IN minus 1 directly. So you know the sum rule for integrals, right? It's basically just two integrals. Their sum of the things they are integrating is the sum of the integrals. Makes sense, right? So secant x plus tangent x n plus 1 plus secant x plus tangent x n minus 1 dx. And then this happily goes to be equals beta 0 secant x plus tangent x n minus 1. But we're not going to put the n minus 1 plus 1 here. Instead, we're going to put a bracket. 1 plus secant squared, secant x plus tangent x squared dx. And then, what do you have? And then you realize that there's actually no half there. Yep, I forgot to put the half here. Half. And then you realize the trigonometric identity that 1 plus tangent squared theta is secant squared theta. So you know that the middle term of the secant x plus tangent x squared is 2 secant x tangent x. So we write that down. And we have the secant squared in the expansion and a 1 plus tangent squared because we add the 1 at the end. So 2 secant squared x dx. We will abuse some notations here. So we are now going to delete all the numbers from here, well, except for the n minus 1 because we're being merciful. Anyways, so this becomes, wait for it, beta 0. Actually, forget it. We don't need another integral because, as you can see, this is actually a chain rule. So basically, you see that this is the derivative of this, right? So this should be 1 over n secant x plus tangent x n beta 0 equals to 1 over n secant beta plus tangent beta n, obviously, minus 1. Yay! We have finished the first part. Let us delete everything that we have done because we don't need it anyway after all. Well, actually we should delete everything except for this monstrous integral right here, which we otherwise happily integrated to produce a not so monstrous result, but still workable. There, we will need this soon. But first, what do we need to do? The most instinctive thing to do is to actually simplify it. So, before we simplify it, we have to solve the other part of part 1. And we see that this is the case. And so IN, you see the subscript is between n minus 1 and n plus 1. But the area is between because secant x plus tangent x is always, and I mean always, greater than 1 for this portion. So basically, in multiplied to the power of n, everything literally gets bigger and bigger and bigger. So IN is less than the average of both values. And because it grows in the terms of powers, it's like saying this. Which obviously isn't the case. So we put a greater sign here, and you realize that the growth is roughly equivalent to the xn plus 1, xn minus 1, and xn, as in roughly equivalent being around that kind of growth. You see that. There. So that Jn is this. Now, how do we do this? So we put the secant x cos beta, and the cos beta is just a coefficient. So Jn, we can safely take it to be beta 0 secant x, actually half secant x plus tangent x and minus 1. And remember, the 2 secant square x used to be tangent x, tangent square x plus 1, and don't forget to put in the cosine beta. And now we will have 2 secant x cos beta tangent x plus secant squared x cos squared beta plus tangent squared x plus 1. And so this cosine squared could be 1 minus sine squared beta. And so this will be, this big bracket will be secant squared x plus secant x cos beta tangent x, or beta, whatever you prefer to call it, minus secant squared x sine squared beta dx. And there you go, another chain rule. So this just turns out to be twice that, actually. Forget it. You know what, scrap the 2's, because we are now going to cancel them away, and so does the half. Because in the algebraic simplification, you can take away 2's and halves at literally the same time. So we are now going to delete this because this is our new bracket. So beta 0 secant x cos beta plus tangent x and minus 1 secant squared x plus secant x cos beta tangent x dx. And there, so this is actually less than the original value of Jn. So you know what this must mean. We are now going to do an integration, obviously by chain rule. So this becomes 1 over n secant x cos beta plus tangent x n beta 0 equals to 1 over n 1 plus tangent beta, don't forget n, minus cos beta. Let me check I got that right. There. And don't forget to put in the cos n beta because there was already an nth power. There. Hence half Jn plus 1 plus half Jn minus 1 is less than this monstrosity. And as we have seen up here, since In is less than half In plus 1 plus In minus 1, and since Jn is just the same as you go up in a coefficient tack onto it, this means that we can safely say Jn is less than half Jn plus 1 plus Jn minus 1 less than half n, 1 over n1 plus tangent beta n minus cos n beta as required. And therefore, in math language, we always put a word shown, or if you're feeling nerdy, you can write this little box right here, and don't forget to color it, like we always do in mathematics. Well, anyways, see you in another step video.